In this class, we're going to look at one of the most commonly used tests in the clinical literature. In fact, as the title tells you here, we're looking at a whole class of tests. There are many tests that go by the same name, and we're going to look at some of the most commonly used ones. I've not named the test because I want to make a couple of comments about the name of these tests. First of all, that X looking symbol that you're seeing is in fact not an X written in a fancy way, but it is a Greek letter, and it's the letter chi. Many people pronounce this letter, many people who don't know what they're doing, pronounce this letter chai. But remember, chai is actually a Chinese T, not a Greek letter. So if you want to show how good and how prepared you are, make sure that you pronounce these tests chi-square tests. As we've seen before, in order to understand these tests, we have to go through the 4 features and try to identify what they are in this particular case. So let's do that. The purpose of chi-square tests is to compare 2 or more proportions or percentages. Of course, we know that proportions and percentages are really the 2 sides of the same coin, so we're not really looking at 2 different things. So it is a fairly simple kind of question that we're going to ask. The statistics that these tests use are also fairly simple. They use n, sample size. In fact, since we're comparing different groups, it may be more than one sample size. P, which is the proportion, or of course percentages, depending on which one we're using. They also produce a statistic called, not surprisingly, a chi-square statistic. And as I'm going to mention again later, this statistic is also often listed in research papers, but it's really a very little practical purpose, so we can safely ignore it. But we're going to see later on what we're going to do with that. The requirements are also fairly simple. The basic ones, probability sampling, we always expect that in an inferential procedure, and independent observations. Remember, this is a requirement which applies to most tests, though not all, but certainly it is expected in this kind of test, in this chi-square test. The other requirement is that we're actually using nominal data. In fact, you're going to see the chi-square test also apply to ordinal data or even sometimes to numerical data. However, when we do that, we're really applying the chi-square test by ignoring any order and definitely any size that comes with the numbers. So when we apply the chi-square test, all we're looking at is the values of certain values of the variable and nothing else, nothing about how those values relate to each other. Another very important requirement, and this is a really tricky one because sometimes, quite often actually, it is ignored or overlooked, is the fact that when we do these tests, certain totals, certain sample sizes have to be predetermined. They have to be fixed in advance. We cannot leave them to chance. And we're going to see that this is quite important in some situations, not as important in others. As I said, this is a requirement that is often ignored, and it's not the end of the world. The chi-square test can work quite well even if these totals are not fixed in advance, but in some situations it can make a big difference, so you still need to look into that issue. Speaking of which, let's look at the robustness. Again, the requirements for the chi-square test are fairly simple, and therefore the test itself is very robust. However, this is only true if the expected frequencies, the numbers that we expect to get, are large. How large? Well, the usual rule of thumb is that each frequency that we're going to be looking at should be at least 5. However, that's a rule of thumb which is so much overused that I'm not even going to write it down. I'm just mentioning it in words and just forget about it. But just generally speaking, just the larger the better. Okay. So usually it is considered as a very safe test, and this is one of the reasons why it is used so often and so commonly, but it should not be used indiscriminately. You always want to make sure that it is used properly in each case in which it is used.